All right, 17 questions. It is a blend, 17 questions. A blend of multiple choice and open-ended, okay? And it's a blend of calc and non-calc. So when we go through the different topics, we'll talk about this could be on the calc portion, this would not be on the calc portion. There are even some things that like you don't need the calculator for, but they're on the calc portion because the calc won't help you, and like, it was just easy for me to split them that way. Yeah.
Did you say they were all open-ended?
No, I said they're a blend of multiple choice and open-ended. Yeah. So it starts 112, which goes back a little bit, but we haven't tested on it yet, and that is all the translations and stuff like that of your functions. So 112 was here's a parent function, talk about all these changes, right? So if you break it apart like this one is, okay, the plus minus all the way on the front does what? If there's a negative, it would be a reflection over what? Good. Yeah. Reflection over x-axis. But what values are changing? The x's or the y's? The y's, right? I would change the sign on the y's. The A, that's next to it, has what impact? Vertical dilation, right? Vertical dilation by a factor of what? Good. And then I'm going to skip all the way to the end because the other thing outside of the parentheses, which is what the vertical changes are, is, in this case, D. If I add or subtract after the function or outside the parentheses, this causes a vertical shift. Okay, positive goes up and negative goes down.
Okay, for the dilation, you multiply it to the x or
The Y. So everything we just talked about affects the Y's. Which also means it would affect what? Domain or range? Range, good. If I have a T-chart, I'm going to change the Y's, right? All the output stuff. Okay, now let's go inside the parentheses. The plus or minus on the front of the B is what? Good. Reflection over the y-axis, which would actually change the x values, but it's a reflection over the y. What's B? Good. Horizontal dilation by a factor of? Good. Factor of 1 over B. So if B was 2, it would be a horizontal dilation by a factor of a half, and I would take all the x values and I'd multiply by a half. And then inside the parentheses, a shift in here is what? Horizontal. If it's positive, it goes which direction? Positive goes left, negative goes right. And those things, all the things inside, okay, affect the horizontal, which means it affects the domain. So how will you see this several ways? One, here's a function that's like literally got a translation on it, like a specific one, and you'd have to describe it. Or one in which you have like a big, like 2 f of x or f of x plus 3 equals, plus 5, let's say, and it would ask you to describe all the translations, okay? You could also see it in your domain and range shifts, and you could also see it in a T-chart, which you'll see an example of in a little bit. Remember that the order matters when we go to do anything that has a stretch. If it's a vertical dilation, then the stretch happens before you move. So if it's vertical, we stretch, then move. So if you thought about how you would solve something that had parentheses, and there was something multiplied on the front, we would multiply by that item on the front, and then we would add or subtract the number at the end. If it's horizontal, it's the opposite. If it's horizontal, we would work innermost parentheses first. So we would move, then stretch. So describe all these translations. The negative on the front. Good. Over the x-axis, the 2.
Vertical dilation by 2.
Good. Vertical dilation by a factor of 2. The 3 inside.
Horizontal by 1/3.
Good. Horizontal dilation by a factor of a third. The -4 inside.
Move
Right 4. The +7.
up 7.
Up 7. So if I was to do the translations that were the verticals, I would first multiply by -2. Change my y's. Then I would add 7. If I were to then move to the inside, I would first add 4 to the x values, shifting them to the right, and then I would multiply by a third. Yep.
Multiply by 2 or -2?
Well, you could do them separately, or you could do it as one. I would probably do it as one. Yeah.
Would it matter if we did like the horizontal stuff and then the vertical? Or just
As long as within the horizontal you do it in the right order, and as long as within the vertical you do it in the right order, it doesn't matter which one you change.
Okay.
Yep. It just, you gotta do, like if it's vertical, you gotta do the stretch, then the move. And if it's horizontal, you gotta do the move and then the stretch.
Do we like move the x and y's or just the y's?
Well, the x -4 means I'm adding 4 to the x values. And then the +7 means I'm adding 7 to the y values.
And the -2 is for both?
The -2 is the y. -2 times y, and the 3 makes it a 1/3, but that's times the x. Yep. Awesome.
It doesn't matter if you do horizontal or vertical first.
No, as long as within it, you do it in the right order. Correct. So again, you'll see this by like, here's my domain and range, and I'd have to tweak my domain and range, right? So like if I told you the domain of this function was 1, 3, and the range was 0, 5, let's some parentheses, some brackets, it doesn't matter, but we keep them the same, okay? So if I was altering this, the domain's all the stuff in the inside. So I would add 4 to the x, which is the domain, add 4 and add 4. Now it becomes 5, 7. And then I would multiply by a third. So it would change my domain to be 5/3, 7/3. And then the range would be impacted by the y stuff or the vertical stuff. So I would first multiply by -2. I'd get, well, that's a bracket, 0, -10. And then I'd add 7. And I'd get 7, -3. And then what?
Rewrite it.
You have to rearrange it so the smaller comes first. So this becomes -3, 7.
Just goes fast.
Yep.
So you get the 0.5.
I made it up. Yeah, I just said if this was the domain and range on this function. So our table of values, we had stuff that looked like this, and it would have said like 1, 2, 3, 5, 7, 10, maybe something like that. And I could ask you to do the same thing on these. Like I could ask you to find f of something. And so what I would do is I would change the values that are actually there. If it was the same translations, I would take all those x values, I would add 4, and then I would multiply by a third. And then I would take all the y values, I would multiply by -2, and then I would add 7. And then use the adjusted table to answer your questions. Yep. What are your questions?
But you still have to follow the order, right?
Correct. Yep.
Would we have to like write an entire new table?
No, I mean, if you just change the x values, know what you're doing. You don't have to then change all the y values. You would only want the x you're looking for. Yep. Or the y, like let's say it said x is, I don't know, these are not the right numbers, but 1/3. Or if it said f of x equals 3, now I know which one I'm looking for, right? If it's inside, I want the x value to be that. If it's equal to, now I want the y value to be that. Okay, then came piecewise functions, and this was also on your quiz, okay? The piecewise functions, you'll see some sort of a word problem, and it's going to give you piecewise, and it could ask you about rate of change on that piecewise, or it could ask you about a specific time or a specific value on that piecewise function, okay? So just like we did with your models, with your regression models, you could be asked the same kind of questions, but based on a piecewise function instead of a regression. Yep.
Just on the table of values, wouldn't you have to write a whole new table of values if you're changing the y and the x?
Well, if you're looking, let's say I was looking for f of 1/3, I would only change my x values until I would change the x values, and I would say which one is 1/3, and then I only have to change that y value. Yeah.
Like that.
Whereas if I'm saying f of x is equal to 3, now I'm going to change the y values first. I'm going to figure out which one is 3 and then work the x values. It wouldn't take you that much longer to do both, but at least you can eliminate some work. Okay. Then came, and notice none of that stuff was calculator related, right? So all the f of stuff, okay, you wouldn't have a calculator, and the piecewise functions you won't have a calculator for. The one you will guarantee to have your calculator for was the stuff that started in 114, okay? It came back yesterday in 2.5 because we added in exponential, but it started in 114. So this is where you're going to get given a data set. It's going to ask you to figure out which quadratic or which function is the best, or it'll just ask you to run a specific regression. So it could say run the quadratic regression, run the linear regression, and then it's going to ask you questions based on it. So I added in here exponential, right? That came later. That didn't come until yesterday. But exponential is now going to be one of your options. So we've got linear, quadratic, cubic, and exponential as options for when we're running to see the best R squareds, those kind of things.
When we do intersect on the calculator, it says first curve and then second curve. How do you do that?
It literally hit enter and it's going to bring you to one of your two. Hit enter again, it's going to bring you to the other two, the other one. And then hit enter again, it brings you to intersection.
Would you have to line up the first curve on?
It should jump to your first curve. It just would be if there was like a y1, a y2, and a y3, you'd have to tell it which two
lines
you're trying to find the intersection of. If there's only two in there, there's only two in there. So it should jump from 1 to 2. Yeah.
Does exponential have an R squared?
Yeah. You run an exponential regression just like you would do every other one. So R squared's just like how perfect the model is. It could be any kind of model. Yep. Nico. Yes. Yes. Yeah, I have, because he was the last, yeah, I have them today. Yeah. That was it?
Yeah, that was
Okay.
I wanted to make sure I studied that.
Yeah. All right, so you'll run your regression, obviously. Okay, it could ask you to predict a specific value. What is it at a specific year? What is it at a specific, whatever it is, where you're just doing your value, right? Your y1 of that number or your value from your table. Okay, and then it could ask you for rate of change, and it could ask you to describe what that means for both, just like you had to do for the quiz. So remember, if it's a specific thing, like what happens at f of 7, if this is time for, I don't know, distance, let's say it's distance and time, then after 7 minutes, seconds, whatever the unit is that I give you, you are at this distance, and that should be feet or miles or whatever it is that they give you, okay? So that kind of thing has to be just explained in words. Also rate of change, which is what the quiz was. So from this to this, whatever the interval is, the average rate of change is blank, blank per blank, right? So the average rate of change is 5.2 feet per second, or miles per hour, whatever it is, you got to give those things.
If it was average rate of change and not just rate of change, the only thing we change would be the average rate of change.
I would give you rate of change or average rate of change. First round is the same. Like average rate of change is the same thing as rate of change for the first one. It's when we do rate of change of the average rate of change, that's when it's something different. For this, it's just regular. Yeah. Okay, and then also in 114 was like our quadratic and our cubic stuff. That here's a model of some sort, answer a question, talk about what's the restriction on a domain, right? It can't, like time can't be negative, or volume can't be negative, something like that, okay, to the maximum point. It could ask you for a specific value. It could ask you for the max value. It could ask you when does the max value happen. It could ask you when does it hit the ground, or when does the diver hit the water, like whatever those kinds of things are, you'd have to be able to answer it, and this would be calculator based, okay? And then also in that section was directly and inversely proportional. So if it said that distance was directly proportional to time, then it would be like that. If it said, it wouldn't make sense, but let's say it was inversely proportional, then we would put it under it, okay? And then I'll give you two things so that you would solve for k, and then it will ask you to either find distance when time is this, or time when distance is this. And we're going to remember that if it says the square of, right, that's that thing squared. If it said square root of, it'd be square rooted. If it said cube of, it'd be cubed. All right, then came 2-1 to 2-3. 2-1 and 2-3, which was kind of all three of those were geometric and arithmetic, exponential, and linear, like all looped in together, right? So here's what you've got to be prepared for. It might ask you to find an arithmetic equation, or it might ask you to find a term in your arithmetic sequence, or it could ask for linear. You got to know those things go back and forth, right? So personal preference, but I think it's easiest if it starts arithmetic, I make it linear because we're way more comfortable with slope-intercept form than we are arithmetic, right? So if I told you that these two were terms in an arithmetic sequence, I would immediately change them into coordinate points. So I would change these to coordinate points, and then I would find an equation. How do I find an equation with two coordinate points? If it's linear. I could do point slope, or I could do slope intercept, right? So first I'd find my slope, 18 minus 5 over 7 minus 2, 13 over 5. And then I would plug it in. Y minus y1 equals 13 over 5, x minus x1. Distribute.
The answer is 2.6.
How do you know? Oh, she just divided 13 by 5. That's not what I wanted. 25 fifths. So this would be y equals 13 over 5 minus 1/5. That, if it asks for a linear, obviously that's it. If it asks for arithmetic, what do I have to change? Y becomes a to the n, and x becomes? What's the variable?
Oh, D.
No, that we plug d in though. This would be an equals, what's my input if it's an? N. So typically they'll even switch this. Order doesn't matter. Negative 1/5 plus 13 over 5n. Like either of those are fine. Okay. If it's multiple choice, you'll see that the variable shifts. If it's not, you got to know to shift it.
Can you zoom out?
Yeah.
This one,
Yeah.
why are you dividing by 5?
I did change in y over change in x. You're finding slope. So y2 minus y1.
But when you move the y,
I added 5. This one, I added 5.
but then you put 13 over 5, and then,
That's the slope. So that came from here.
okay.
And then I distributed.
Oh.
Yeah, and then I added the 5. 25 fifths. Yeah.
Yeah, okay.
Yeah.
Wait, why does the negative 1/5 have to come before the 13 over 5?
Why what?
Why does can you either
'Cause
get it right? Is that what you're saying?
These two either are good.
Oh,
If it says arithmetic, you have to change the variable.
okay.
Yeah. Okay, then geometric, okay? When it's between geometric and exponential, I actually go with geometric because of our big little trick, okay? So if it gave you something and it said this is a geometric sequence, or it gave this to you in terms of exponential. So this could be, here's two terms in my sequence, and then find an equation. Here's two terms in my sequence, find a specific term, okay? Any of those things. You would need to know how to do this with and without a calculator. So with a calculator would be like a real world scenario like we did last week with that FRQ. There's a population of something. Could you find an exponential function? So you would plug it into the calculator like I could do it here. I would go to my stat. I would edit it to be these two terms. There's only two. So if you want to practice. It's 2 and 7 and then 5 and 18. So my x values or my L1 is 2 and 7 and my y values 5 and 18.
Wait, why do you put into the calculator?
You can't, so you're going to have two different types depending on how big these numbers are really. You got to know how to do it both ways. Like if this was 192, I wouldn't expect you to be doing, does that make sense? Yeah, okay. So I can run this regression, again, with or without the calculator. With the calculator, I literally go stat, I go calc, and I go down to exponential. And I get y equals a 2.995 times b 1.292 raised to the x. So using the calculator, I got that.
Can you always put the calculator?
No, you won't always have it.
I'm gonna take my calculator.
No, I'm going to tell you to put it on the ground. And then you'll go to put your paper on the ground, and I'll be like, no, paper stays, calculator goes.
Which paper?
Even though we're how many days in and how many tests and quizzes in. Okay, so the other, and then if it could ask you from here, it could ask you to predict something at a specific time. So it could say what happens at year 10. Okay, I got to plug in 10. It could say when does it hit 25. So I do y1 equation, y2 25, see where they cross. Okay, it could ask you to do rate of change with this. So I would store the rate. All of that stuff you could be done on the calculator after you get the regression. The other way to do it is without the calculator. So this A2 is 5 and A7 is 18. I do the big little thing. So A7 equals A2 times R to the 5th. If you don't have a calculator on this one, this will be a number you can find, okay? It would be something you could actually fifth root. So this is 18 right now. This is 5, R to the 5th. Divide by 5. R to the 5th equals 18 over 5. So again, without a calculator, this would be something attainable. Like you would be able to actually find this.
Where did you get the first number 2.995?
I ran the regression in my calculator.
Okay, but how do you find that without the regression?
You'd have to fifth root this. This would have to be fifth rootable.
No, like the 2.995, not the.
Oh, you'd have to go backwards to get to A0.
Oh.
This is A2,
Okay.
right? So good question. If, let's say let's just make this a number that we could do. Let's just get rid of the 5. What's 2 to the 5th? 32? Yeah, okay, so let's say this is 32. So R is 2, for example, okay? Let's say it's something that you can actually find. So now if I want an equation, you have to pay attention to how it asks. If it says you need an equation and it needs to be an f of x equals a b to the x, then what does the exponent on this have to be? You can't add and subtract anything here. That means this has to be a0. Does that make sense? So if this is x, this has to be a0. Which means in this scenario where I have a2, I'd have to go backwards twice. Does that make sense? So if it was 2, if r is 2, I would take 5, divide it by 2, that's a1. And then to get to a0, I'd have to take 5 halves, divide it by 2 or multiply by half, and it'd be 5/4. So if I have where the instructions literally say it has to be a b to the x, then I cannot change this exponent. It has to be 0, which means this base has to be a0. Yeah.
How do you know that's multiplying by 2?
We solved for r, and I pretended that it was something we could actually find. Yeah.
Wait, so like how'd you find like the equation? Like,
Big
wouldn't it
little.
be- No, but wouldn't it be 13 minus 5 for the r? Because it was bigger minus smaller.
It's the base, though. So it's base. Big base, small base, different between the bases.
18 minus 5 is 5.
No, between the bases.
Oh.
7 minus 2.
Oh.
Yeah.
Okay, I thought
Remember,
it was
the exponent here has to bridge this gap. It has to get me from the second term to the seventh term. So it has to be the difference. Yeah.
Let's say if we had a problem, like the people, like, how would you want us to give you the answer? Like, would you accept like a square root?
So if it was, so let's say that this is without a calculator, and it doesn't say it has to be x to the or this has x plus or minus 0, whatever. Then I would say you could keep that. So I would keep my r is the 5th root of 18 over 5, right? That's what that was. And then you can use either of these terms. So I could say an equals a2 times r to the n minus 2. And then I can plug in what I know. An equals a2 is 5. My r is the 5th root of 18 over 5 raised to the n minus 2. If it didn't tell you, it had to have just the exponent by itself. Or you could use a7. An could equal a7 times r to the n minus 7. And then I could plug in 18.
And would we ever have to simplify the denominator?
No.
if we have a square root?
No.
If we don't
Like
have
in the
to-
world of rationalizing, yes, when we get to like trig and stuff, we'll rationalize. But for now, you could leave it.
Okay.
So how do we know when to use that minus 7 and minus 2?
If you look at the instructions, if it says find an exponential model, you could do whatever you want. If it says it needs to be in the form of a times b to the x, this has to be a0. And that has to be b to the x alone. Does that make sense? Okay, yeah. If you have a calculator, it's going to put it in that, so it wouldn't even matter.
When you did it with the calculator, how did you know it was, you like had to do the exponential one?
In the instructions, it said it was geometric.
And geometry.
So geometric, exponential, same. Yep. Questions? Okay. Then came the comparison between geometric and arithmetic. Remember, geometric and arithmetic have dots, right? If I was looking at a chart, or a graph, they would have dots because they are discrete points, whereas exponential and linear are smooth and continuous. We can go back and forth between, like this could be linear. It could also be arithmetic, right? So when it's asking for the slope, it's the same thing as the common difference. And if it's asking for the ratio, it's the same thing. R and B are the same thing, okay? So if you're looking at this one, what's the slope of f of x equals 2x plus 3? 2, right? 2 over 1, 2. What's the ratio, common ratio, in 4 times 2 to the x? 2. It's the b, the base, right? Whatever's being raised to the power. All right, then came how can I determine if it's exponential or linear? Well, if I'm looking at a set of data, how do I know that it's exponential or linear? Good. If you're adding by the same thing each time, it's linear, which is arithmetic, right? And if you're multiplying by the same thing each time, it's geometric or exponential. So then it could ask you to now take that data and find the equation. And with those, you would not have a calculator, okay? So you'd have to be able to get A0 if it doesn't give it to you, and you'd have to get B. All right, then came exponential growth versus decay. So if my model is increasing as I'm moving from left to right, then it's got growth. And if it's decreasing as I move from left to right, it's got decay. In both of these scenarios, A is greater than 1. On the right-hand side, you're saying B is greater than 1. So it has growth. And on the left-hand side, it's in between 0 and 1. So it has decay. Just like from the notes in this section, it's going to ask you on and it's all the whole ways, either increasing or decreasing. It's either concave up or it's concave down. And then it's going to ask you to describe the limit, use limit notation to describe the end behavior. Remember, you're looking for a horizontal asymptote, right? So it's either equal to positive infinity, negative infinity, or wherever the horizontal asymptote is. So these are either going to be infinity, negative infinity, or the location of the horizontal asymptote. How do you know if something has a horizontal asymptote? What is a parent function of an exponential? Where's the horizontal asymptote? 0. And how does it move? Up or down, vertical shift. Yes? So if I take and I add something after, if it said 3 to the x plus 2, I just took my growth model and I shifted it up 2, which means I have a horizontal asymptote at 2. And the left hand of this behavior, the left would go to 2. The right would go to positive infinity. You look like I'm lying to you. I promise you that's how it is.
How is that a horizontal asymptote?
Because it's a shift up. Horizontal would move if I shifted up or down, right? Okay.
Wait, so which side would be 2 and which side would be?
In this example, the left side is 2 because it has growth. So it would start like that. So left side would get closer to 2. Right side would go to positive infinity. Yeah.
For growth, is it always going to be increasing and then
Yeah. Yep. Growth is always increasing. Decay is always decreasing. Okay. 2-4. This was Fridays, right? So it was like name the transformation because sometimes you can see the same model described 2 different ways, right? So we found out that a vertical stretch or like a vertical stretch could be the same thing as a horizontal shift, right? I could take 16 and I could rewrite this as 2 to the 4th times 2 to the x. And then when we multiply 2 things that have the same base, what do you do with the exponents? I add them. So this becomes 2 to the x plus 4. So if I'm describing the translation on the initial, you tell me it has what kind of transformation? Vertical dilation by a factor of 16. And now, how else could it be described? Horizontal shift, left 4, okay? Both of those could describe the same graph.
What was the first one again?
Vertical dilation by a factor of 16.
Okay, thank you.
Yep.
So would you put both dilations?
So if it said, you know, describe all the ways, you could do both. It could say, what's an additional way? And then you're only giving one. It could be a which of the following are true. And it could be both.
So we should put both?
Yeah?
Okay.
Yeah.
So if it says describe the transformations, do we have to put both?
Yeah.
Even if they're just saying the same
Well, but
thing?
the point of this would hint that there was another way to describe it, in which you'd be able to say.
Well, that's
Yeah.
a vertical dilation by factor.
The initial would be a vertical dilation by a factor of 16,
Okay.
but the translated one would be to the left 4. Yeah.
When it says an additional one, would it just be the second one?
Yeah.
Okay.
Yeah.
On the test, do we have to be like specific whether it's a stretch or compression?
No, you could say dilation by a factor of, which is exactly how the AP will. It won't ask for stretch or shrink. You'd have to know, like, if I took a graph, what it's doing to it. So, like, you would know that if it said 2 f of x, it's multiplying the y by 2. And if it's inside, it'd be multiplying the x's by a half. So you have to know how to do that, but you don't have to use the word stretch or shrink. Yeah.
Would we get points off when we do whiteboard?
It's not going to happen. Yeah. All right, so then go to the next one. Now it says f of x over 8, and I gave you f of x is 2 to the x, so this is 2 to the x over 8. What's one way to describe this?
Vertical dilation by an 8.
Good, so I can make that 1/8 times 2 to the x, which would be a vertical dilation by a factor of an 8. Or I can rewrite 1/8 as 2 to the negative third. And then we're multiplying, same base, so this becomes 2 to the x minus 3. And how would you describe that? Good. Okay, last one on this kind. So this is saying f of x to the third. So this is 2 to the x raised to the third. So that could become 2 to the 3x. And now we're going the other way, right? What is one way to describe this? If I leave it as it is, horizontal dilation by a factor of? A third, good. If I split it, this is really 2 to the third raised to the x, which is 8 to the x. So a power to a power can become a change of base. So a horizontal dilation can also be a change of base. So it might give you one and say, which of the following is the equivalent? And you'd be picking it from that. Or describe the equivalent, and you'd be describing it.
What does change of base
Wait,
like
what?
do?
Change of base would just take all those numbers and make them jump faster,
So,
which is the
it's
same thing as
thing
shrinking your x values.
It's the same thing as the horizontal diameter.
It looks exactly the same. You get the same exact points.
So we only have to write like horizontal diameter. We don't have to say change base.
Well, it could ask you what the equivalent is.
Wait, so when you change it, 8,
So like think about coordinate points here, right?
but then what would that translation be?
It's a completely different, the parent function is different. Yeah. Every value that we plug in is going to be a higher y.
Okay.
Because 0, if I plug in 0, they're both 1. But as soon as I plug in 1, they become the same points because they would be different things, but they result in the same points. If that makes sense.
Yeah.
Like if I plug in 1 to 2 to the 3x, it's still 2 to the third, which is 8. But if I plug in 1 here, it's just 8 to the first, which is still 8. So they result in the same points. All right. And yesterday's, okay? 2.5, exponential function, context and data modeling. The good thing is like this, we did so much in 114 that hopefully it wasn't terrible, right? It was running a regression again. As the regression part of it, you know how to put points in and run a regression, yes? Okay, so it's going to give you, or it could give you either a t-chart with some data, and then it's going to ask you to run the regression, and then it's going to ask you to do the same things we've been doing. Find a specific, like what's an output value when this happens, or when does this happen, okay? And those are the ones you have to be careful on, right? Because if the wording says, after how many years will it be 1,000? I Y1, I Y2, I see where they intersect, I leave it. I don't have to worry about that converting into years. So if I crossed at 10.2, I could say after 10.2 years. But if it says during what year does the population hit this, that's when you have to bump it up. So if it's 10 years later, but it's 10.2, that means it's really during the 11th year. So if I cross two things, right? Like if I run a regression on my graph and I've got my exponential model and then I've got my horizontal, and this, my goal was to find when f of x equals 50, for example, okay? So I have my model that I saved because I ran the regression, And then I have my y2, that's 50. And my goal is to find out when they cross. Now let's say this coordinate point is 5.2, comma 50.
6.
I have to go to the 6th year.
Even though.
Because at 5, I haven't hit it yet,
It's
right?
not
So if
allowed
it
yet.
started in 2010, for example, then 2015, it hasn't hit 50 yet. I have to go to 2016. Does that make sense? So if it says, how long does it take to get there? 5.2 years, I'm done. But if it says, during what year does the population hit blank? Now I have to bump it up, even if it was 5.01, because it didn't happen until it passed into that next year. Does that make sense? Okay.
Isn't